One more problem to practice analytically. You'll notice that this is a radical equation that has two radicals included. So the way we approach this is pretty much the same as what we're starting with. You always want to make sure that you have at least one of the radicals isolated first. So you'll notice right away the way it's written, the square root of x plus 18 is already isolated for us. So we can go straight into raising each side of the equation to the index of this square root of x plus 18. So the index is 2. Now be really careful. The square root of x plus 18 is going to be just x plus 18, because when you square a square root, you get the radicand back. However, when you look at the left-hand side, and I think I'll move this over just a little bit. Okay. You're getting a binomial squared, so I want you to be really careful. This is still a binomial, well, binomial-like expression, if you really want to be precise. That's being squared. So if that is the case, what we need to understand is that you will be rewriting it twice. So I have 3 plus square root of x minus 11 times another 3 plus square root of x minus 11. So I always do that to remind myself what do exponents mean in the first place. And now with this binomial-like expression, in order for you to simplify, you have to distribute or use the FOIL technique. Or if you have a shortcut, it could work, but be careful. So 3 times 3 gives us 9. 3 times square root of x minus 11, we get a 3 radical x minus 11. Same idea. Square root of x minus 11 times 3 is another 3 times square root of x minus 11. Now, when you multiply square root of x minus 11 times square root of x minus 11, you are just left with the radicand back, x minus 11. This is still equal to x plus 18. So now we just take a little bit of time and care to clean up the left-hand side. If you notice with me, I have a 9 minus 11. So this is going to leave me with negative 2. I'm also taking a look at my like terms that have radicals with them. This should give me plus 6 square root of x minus 11. And I'll make that 6 a little closer so you know that's considered one term. And then I just have a plus x. So nothing's changed there. So we already took care of the, just to remind you, the 9 and the minus 11 to be negative 2. So we still have the x plus 18. Now, you did get rid of one of the radicals, but in this process, we still have a radical that is left over. So guess what? We get to repeat the process one more time. So remember, before you can square both sides, we need to make sure the radical term is isolated. So what that involves is us subtracting or adding, depending. I'd be making sure that I move the 2 over by adding this to both sides and subtracting the x from both sides, just so that I have my radical term, 6 square root of x minus 11, isolated completely. So that leaves me, the x's cancel out. 18 plus 2 gives me 20. So that's good news there. At this stage, notice that we'd want to get rid of our radical. Now we have a factor, 6 times square root of x minus 11. This is a little nicer. You can directly square this on both sides. So that if we have this, we raise each power to the power of 2, or each side to the power of 2. This will give me 20 squared is 20 times 20, which is 400. Now, consider this a little bit more in depth. If you are using this, dealing with the radical side, what's really happening is you have 6 times square root of x minus 11 times another 6 times square root of x minus 11. And this is a case that you have a factor being squared. So what ends up happening when you multiply these, this is not a FOIL issue like we had previously above. You really end up saying this is 6 times 6, which is 36. And square root of x times, square root of x minus 11 times square root of x minus 11 is just the x minus 11. So you could skip the intermediate step. This is the idea of having a factor squared, where it pretty much raised each factor to the power of 2. So that's one way to approach it. I'm reaching for a calculator because I'm sensing some numbers are going to get a little larger. If not, at least I have it by my side. So now what I'd like to do is simplify the left-hand side. So 36 times x minus 11, we got 36x minus 36 times 11. That's giving me 396. A little large there. Glad I reached for that calculator. So at this stage, I'm just solving this linear equation. I'll add 396 to both sides. So 396 plus 400 is 796. Having a little fun here, I suppose. 796. And I still have 36x. So if I'm going to solve for x, I would divide both sides by 36. And I should get x equals. I probably would see if I can reduce. They're both nice, even numbers. So 796 over 36. Maybe I'll use my fraction key on my calculator. I end up getting 199 over 9. I mean, it's not a great number, but it looks a little prettier than what we started with. Now, before we circle it, we must remember that we have to check it. If we don't, we could have this extraneous solution. So what I will do is go back to my original equation and just kind of maybe label this side work as your checking part. And I'll double check what is happening. So I have 3 plus square root, I'll write it over again just so you see this, x minus 11 equals the square root of x plus 18. I mean, I'm not too excited about having to check it, but we have to do what we have to do. So we're going to test, again, it's x equals 199 over 9. And this is where I would encourage you to maybe use the fraction key just in case, and maybe I'll show you. Okay, so if we try to check it, we have 3 plus 199 over 9 minus 11 equals. We're actually not sure about it equaling, so that's why we're drawing a question mark. Square root of 199 over 9 plus 18. So as you can see, super not excited about having to do this by hand, but we can pull out our calculator and let's test it. All I want to do is simplify it on the inside. Hopefully I'm getting a nicer number I can deal with. So I'm going to go to my home screen, and all I'm doing is looking at 199 over 9. So there's a couple ways you can do it. And I'll double check what I'm supposed to be subtracting again. Minus 11. Now, if you press equals right away, it's going to give you a decimal, or maybe it won't, maybe it will, but I'll make sure. I'm going to change it to fraction form just in case. And we have 100 over 9. So let's include that in our statement. Go back. So I end up having 3 plus square root of 100 over 9. That's looking a little bit more friendly. And I still want to test out, I'm not sure. I really want to know what 199 over 9 plus 18 is. Is it going to be a nicer one too? We will see. So let's go back to our TI. And we're looking at 199 over 9 plus 18. I'll change it to a fraction right away, pressing the math key. And here I get 361 over 9. Well, let's see what happens there. Oh, let's switch back for you. I'm sorry. Here we go, 361. I'll double check one more time, just in case, on my own. There we go. We still have that. Good, good, good. Okay. So remember, we just combined it to have a nice fraction. Now, at least, I mean, I can simplify this radical. Square root of 100 is 10, square root of 9 is 3. It's a little nicer. And 361, you know, I really don't know off the top of my head if this ends up being nice. So let's see. I'm taking the square root of 361 and I'm actually getting a 19. Square root of 9 is 3. So we kind of want to see is 3 plus 10 thirds, 19 over 3. This time I'll use my brain because I don't want to switch back, but I need a common denominator, so I multiply by 3 over 3. And I see I have 9 over 3 plus 10 over 3 equals 19 over 3, question mark. It does equal the same thing. So we got a true statement. And if it's a true statement, it means our solution works. So finally, you can restate it or you can circle it. You can just remind yourself that the solution happened to be 199 over 9. Look at that. So sometimes you don't get these nice integer answers, but they do end up working. So this is the importance of checking and just being really careful with a lot of the steps that we take. There's always opportunities to make minor mistakes along the way, but as long as you're showing your work, a lot of times you can catch yourself maybe after you make them, but you can actually find out where you made the mistake. But luckily, we didn't make too many mistakes along the way. We'll use our TI to help us confirm. And at this point, you might be a little exhausted of all this analytical work, and you're probably wondering, is there a way to solve these with our TI? And I wanted you to wonder this because yes, there is. And so you'll see how to do this in some of the next examples. I'll see you then.